Okay, both sections 6.2 and 6.3 deal with solving trig equations. And 6.2 is just called part 1. Okay, so I'm going to start with some sorts of trig equations that we've actually solved before. I'm just going to work in radians. So my directions are going to be part A, find all solutions in the interval from 0 to 2 pi. And notice I'm including 0 there, but I'm not including 2 pi. So it's a closed interval on this end, it's open here. Essentially that's saying if an angle that would land here is a solution, write 0 as a solution, but don't write 2 pi. Okay. So we're essentially just going around the unit circle once, starting at 0 and then ending just before we would hit 2 pi and start over again. Okay. And then part B, we're going to find all solutions. So we've done some things like this before, although it was before we had been working in radians, and I want to just review how that works. So let's say I had 2 cosine of x plus 1 is equal to 0. Okay. So the first thing I would want to do when I just have one trig function, and it's not squared or multiplied by any other trig functions, I want to just isolate it. So I want to get things to look like a trig function equals a number. So I'm going to subtract 1 from both sides. So I get 2 cosine of x is equal to -1. I'm going to divide both sides by 2, and I'm going to get cosine of x is equal to -1/2. Now, even if I didn't have part A of these directions, if I was just asked to do part B, I would still do part A first. Okay, so what I'm going to do is I'm going to think about what quadrants am I going to have a solution in. So I'm looking for the quadrants where cosine would be negative. So cosine's positive in quadrant 1, there's no solution there. But I'm definitely going to have a solution in quadrant 2 because cosine is negative there. Now in quadrant 3, cosine is again negative. So I'm going to draw another picture. I'm going to have another solution here in quadrant 3, but I won't have a solution in quadrant 4 because cosine would be positive there. And for the most part, I can expect to find 2 solutions. If I'm setting a trig function equal to a positive number, there are usually 2 quadrants where it's positive. If I'm setting a trig function equal to a negative number, usually there are going to be 2 quadrants where it's going to be negative. So in general, I'm going to expect to find 2 solutions to an equation like this in the interval from 0 to 2 pi. If I were working in degrees, I would go from 0 to 360, but the problem would state that. I will just give you a heads up. There's a point in the book where they say, here are a bunch of equations. If it's in terms of theta, work in degrees. If it's in terms of x, work in radians. So do just make sure that you read those directions as you're doing the homework. I will be consistent with them. I'll use x if we're working in radians, and I'll use theta if we're working in degrees. That's not a universal convention, but that's the convention of our textbook. Okay, so I've got these 2 things. I figured out the quadrants. Now I just need to figure out the reference angle. Because I can see in this quadrant, x is just going to be pi minus alpha, because pi would be over rotating, so I've got to subtract alpha to get back to x. Here, x would equal pi plus alpha, because I'm rotating past pi. So I just need to figure out what alpha is, but what I know is that cosine of alpha will be the absolute value of -1/2, which is just 1/2. So now I want to think in terms of my special triangles. Have I seen that value before? And I have. That shows up in my 30, 60, 90 triangle. Some of you might just have the unit circle down. I'm a more of a triangle person, so I just always draw my triangle. 1, 2, √3. Do make sure the shortest side is 1, and that's opposite the 30. The biggest side is 2, and that's opposite the 90. Okay. So now I can see the angle whose cosine is 1/2 would be 60 degrees, but that's pi over 3 in radians. So this is pi, which I can write as 3 pi over 3. minus pi over 3. That's going to give me 2 pi over 3. And here this would be pi, which again I could write as 3 pi over 3 plus pi over 3. That's going to give me 4 pi over 3. Okay. So all solutions between 0 and 2 pi, that would be 2 pi over 3 and 4 pi over 3. Those are my two answers. Okay. Now, to get to all solutions, I basically need all angles that are coterminal with these two angles. And I'm going to get my coterminal angles, remember, by just adding some number of full revolutions. Could be a positive number, could be a negative number, but it's got to be an integer multiple of 2 pi to correspond to a full revolution. So I would have 2 pi over 3 plus 2 pi n, or 4 pi over 3 plus 2 pi n, where n is an integer. Okay. Remember, this fancy z is just the set of all integers, and integers include negative numbers. So n could be 0, it could be 1, 2, 3, any of those counting numbers. It can also be negative 1, negative 2, negative 3, etc., etc. Okay. So that gives me all solutions by adding this, and let's include specifying what n is. That is an important part of the answer. Okay, excellent. So we've done that before, but we've mostly done that when we were working in degrees. Now we're saying that we can do it in radians as well. So I'm just going to give you folks one to work on. Let's say I have 2 sine x plus root 2 is equal to 0. So I'd like you to just pause the video, work that out. Same directions. Part A, find all solutions between 0 and 2 pi. Part B, find all solutions. Pause the video, then tune back in. Welcome back. So, first thing I'm going to do is isolate my trig function. So I'm going to subtract root 2 from both sides. So I've got 2 sine x is going to equal negative root 2. Then I can divide both sides by 2. And so sine x is negative root 2 over 2. So, again, I'm going to think in terms of quadrants. This time I'm looking for where is sine negative. So no solutions in quadrant 1 or 2, because sine is positive in both of those quadrants. But sine would be negative in quadrant 3, so I'm going to have a solution there. And in quadrant 4, sine is also negative, so I'll have a solution there. And if I'm looking for solutions between 0 and 2 pi, the way I want to get into quadrant 4 is rotating in the positive direction. I'm not looking for this negative acute angle, because even though that will have a sine of negative root 2 over 2, I'm first of all looking for solutions in the interval from 0 to 2 pi. Okay. All right. So I've got a picture of my two solutions. And I can see here my x is going to be pi plus the reference angle alpha. Here, this is alpha shy of 2 pi. So x will be 2 pi minus alpha in this case. And then I need to say, well, what do I know about alpha? What I know about alpha is that, this was a sine question. Sine of alpha is the absolute value of negative root 2 over 2. So that's just root 2 over 2. Now, that should look familiar, so either from my knowledge of the unit circle, or I prefer my triangles, I draw my 45, 45, 90, 1, 1, root 2. I know that sine of 45 degrees is 1 over root 2, but I've done that often enough I recognize that's going to rationalize to root 2 over 2. So my reference angle here is pi over 4. So this is pi, which I can write as 4 pi over 4. Plus alpha, which is pi over 4. So that's going to give me 5 pi over 4. 2 pi, I can write as 8 pi over 4 minus pi over 4. That's going to give me 7 pi over 4. So those are my two solutions between 0 and 2 pi. 5 pi over 4 and 7 pi over 4. And then if I wanted all solutions, I've pretty much found the locations on the unit circle that are going to give me the right value of sine. I just need all angles that land at those points. So that's everything coterminal with one of these. So we'll have 5 pi over 4 plus 2 pi n, or 7 pi over 4 plus 2 pi n, where I do need to introduce that n is an integer. And I can write that in words, or I can use this shorthand to say n is an element of the set of all integers.